Okay, I'm going to give you an example of how you can find an inverse of a function. So given this function here, f of x here equals this, and the domain is that x can be anything on the real number line, but it cannot be the number 5. Because if you try and put the number 5 into here, then this bubble here will be 0. And then if that's 0, then this whole thing here, if that's 0, then this bit here will break down. Well, if this bit here breaks down, then you can say that the whole function here breaks down. So it cannot be the number 5 itself. So remember that there are lots of ways of imagining what a function is. We can imagine a function as, at the moment, is this: 3 over 5 minus x, and then plus 7. So we're going to put in a number into here. Let's just call it purple, and then it will spit out a number. Let's just call it black. Okay. So at the moment, this here is our function. We can put lots of different numbers into here, and then it will spit out whatever number out here. But when you're trying to find the inverse of this function here, you're really trying to find you're really trying to make up a machine where you tell it to do something here, and then if you put this number into this machine here, if you put this number into here, the black number here, and then it will spit out the original number over here. So basically, you're trying to find out the inverse of the whole thing here. So it will spit out this number here. So basically, at the moment, our function is this: you put in purple, it will spit out whatever black over here. So now you're trying to invent a machine here where you put in this number, and then it works backward to find out what you originally put in. So you're trying to find out a set of instructions here, which will well, it's you finding out the inverse. So to do this here, to start this off, let's say let f of x here equals y. Just to say that this whole thing here is y. So at the moment we've got this: y equals 3 over this here, and then plus 7. So yes, we could leave it as f of x here, but let's just call it y, and then later we can change it back to whatever we want. Okay, so at the moment we've got this function here. Okay, you're trying to rearrange it so that x is now the subject. Okay, so here, so imagine this as being one block adding this block here. So kill off this block here. So inside your mind, take away 7 from both sides. So it will be y take away 7 equals 3 over 5 minus x. Okay, and then imagine this as being a bubble here, equal 3 over this bubble here. So times both. Actually, take the reciprocal of both sides. There are lots of ways of doing this. You can multiply both sides by this bubble here. But let's just take the reciprocal. So it would be this: 1 over y minus 7 equals 5 minus x over 3, and then times 3 to both sides. It doesn't. There are lots of ways of doing it. It's not that important here. So it's this here, and then you've got this here. So now you've got this block equals this block, take away this block here. So at the moment, your eye should zoom into the x. You're trying to get x on its own. So at the moment, it's a negative x. So add x to both sides. So add x to both sides. So it will be 3 over y take away 7. Add x here, and then this here equals 5. And now at the moment, you've got this block here equals this block. This block plus x plus equals 5. So now take away this block from both sides. So x here equals 5 take away 3 over y minus 7 here. So we've actually reversed the whole thing. So now you can actually say you can actually say this: the inverse of x here equals 5 minus 3, and then change this y to back to the x here, because at the moment we've got a function where we say we're going to put whatever is here, whatever x is here, we're going to put it into whatever x you see over here. Well, the x that you see over here is this. So basically, we just use the y as a dummy variable, if you like, as a thing that we're going to discard after using it. Well, it's just a technique. So the inverse function is actually this. So originally we had a machine here where we had, what was it, f of x. Oops, hang on. We had f of x equals what? Hang on, let me have a look. I can't remember. Bear with me. So here originally this was our function here. So now we've invented a machine where if you put in the well, we've invented a machine to work backwards. So now this function here is 5 minus 3 over x. Now this machine here can work backwards. So whatever you put into here, it will work backwards to find out what you put in the original machine, if that makes sense. Well, anyway, the inverse function is given by this. Okay. Now you got to look at the domain. What's the domain of this function, this inverse function here? Well, the domain, find out what really breaks this function down. What breaks it down is when this thing here is 0. So when is this thing here 0? Well, this thing here is 0 when x is 7, positive 7. So the inverse function is this here, and then you've got to say, oh, the domain will be anything on the real number line except from when x equals a positive 7. Okay. Oh, sorry, except. So this here is a domain. So it's saying you can have anything on the real number line, but not the number 7. Okay. So the inverse is this, and the domain is this. Okay.